Newton came up with three laws. Newton's first law of motion states that when no external unbalanced force acts on an object, its velocity remains constant. And we can do two examples of this. One is my little whiteout here. My whiteout right now is traveling at 0 meters per second. Still traveling at 0 meters per second, still traveling at 0 meters per second. And unless there's an external, that means outside, like my hand, pushing it away. So unless there's an external unbalanced force acting on it, it's going to stay here forever and ever and ever. The same goes for a moving object at a constant speed. So let's look at the example of a car. So when we drive a car at 80 kilometers per hour, your body is moving at 80 kilometers per hour. It's just you're sitting inside the car. If you hit your brakes suddenly, your body wants to continue moving at the 80 kilometers per hour, and you may find yourself approaching the windshield. So your body lunges forward if you suddenly hit the brakes hard. It says to solve this problem, hitting your head on the glass or the windshield, what we do is we've installed seatbelts to hold us back. So that's why we actually move forward, because your body wants to continue traveling at 80 kilometers per hour, even though you actually hit your brakes to stop. We then move on to Newton's second law of motion. So remember back my little whiteout here. So it's going to stay at rest, for instance, that's uniform motion, unless I apply an unbalanced external force, which was my hand pushing it. So Newton's law says if an external unbalanced force acts on an object, that object actually accelerates in the direction of the force, which means if I push this to the left, it's going to accelerate and move to the left. If I take this little object and I push it to the right, it's going to move and accelerate to the right. And we have this formula here. F net is equal to ma, which looks really similar to our force of gravity formula. Our force of gravity formula was Fg is equal to mg, g being the acceleration to the earth. This applies to any applied force. This one applies to any applied force. So remember, F net and unbalanced force mean the same thing. Now I want to do an example using this formula. So here's my example. It says a net force of 36 newtons forward is applied to a 0.24 kilogram ball. What is the ball's acceleration? So as always, you start by writing down our given information. F net is equal to 36 newtons forward. Draw a little arrow in. And the mass of the ball is 0.24 kilograms. So mass is equal to 0.24 kilograms. And we're looking for the ball's acceleration. We're looking for A, question mark. So our formula for force is simply F net is equal to ma. To get A all alone, we have to divide both sides by m. Divide by m, divide by m, m's cancel, and we're left with A is equal to F net divided by m. And then all you do is you plug in what we know. So we know the F net is 36, m is 0.24, and when you put that into your calculator, you end up with 150 meters per second squared forward.